All right, multivariable calculus. Ms. Deer is back on the mic here. I just wanted to talk a little bit about the idea behind Jacobians. I know I gave you a really long video to watch, and I hope you did not watch it on super fast forward. But you know, the general idea here is that we're going to take, last year we took a function, so we have some antiderivative of f of x dx, and we turned it into the antiderivative of some g of u times g prime of u du. This is our u substitution. So if we take that idea now, and we're going to take a double integral of f of x, y, that's an a, over some region, this is going to turn into the double integral of f of, well, since x can be a function of two variables and y can be a function of two variables, we have f of g of u and v, h of u and v, and then we have du dv. The thing is where is this change going in here? So this is going to be our change of variable, and it's called a Jacobian. And so as you hopefully saw yesterday, the way we're going to find our Jacobian is that we're going to take the partial derivative of xy over the partial derivative of uv. And the best way to do this is, of course, to put it in my favorite thing, because I'm terrible at memorizing, in a matrix. So we put in the partial with respect to u, the partial with respect to v, the partial with respect to u, the partial with respect to v, and when we find the determinant of this, we get the formula, which is the partial of u, the partial of v, minus the partial of u, the partial with respect to v. And it has to always be a positive number because we're looking at the area of the region. And even though this looks really scary, it's pretty straightforward. So the one example I wanted to show you is we know that when we're going from rectangular to polar, x is our cosine theta, y, let me see this, is our sine theta. So if I want to do a change of variables from x and y to r and theta, notice that x is now a function of two variables and y is a function of two variables. So if we look at our Jacobian, instead of using u and v, I can think of my u and v as being r and theta. So I can go from a double integral with respect to x and y to a double integral with respect to r and theta. So if I look at what is the Jacobian going to be for polar coordinates, well, that's going to be the partial of xy, r theta, which is going to be the partial derivative of x with respect to r. Well, what is that? So if I just write this out, it's going to be the partial with respect to r, the partial with respect to theta, the partial with respect to r, the partial with respect to theta. So this is going to be cosine theta times r cosine theta minus sine theta times negative r sine theta. So this is going to be r cosine squared theta plus sine squared theta, which is just r. And this totally goes along with what we know. When we switch up from rectangular coordinates to polar coordinates, we always add an r right inside of here. So when I have dx dy and I switch to dr d theta, this is my change of variable that goes right inside of there. All right, so I'm going to do another example in the next video, but hopefully this makes you feel good that, again, math works and it all makes sense. See you soon.